today we're talking about finding the area of regular polygons. Remember, regular means they all have the same what? Well, let's start the other way. Polygon means what? Shape. Okay. How many sides does a polygon have? What's that?
It can have as many.
Okay. What's the least it can have? How many?
Three.
3. What's the most it can have? Unlimited, right? Now, at some point, it starts to look like a circle, though, doesn't it? Because there's so many sides, and they're so short, and the angles are so big, and so they look like a circle. But typically, we just talk about sides from 3 to 6, 12. Okay, remember we gave you names for all the way up to 12, skipping 11. And I asked you to research that and tell me what the two names were for 11, and nobody come back to me with that. So we didn't talk about that anymore. But so that's a polygon. Thank you.
Yep.
Now, go back to the word regular. What does regular mean? Jackson Miller, what do you think? What's regular mean? Normal? That's an interpretation of the way we use regular. He's a regular guy. He's a normal guy. It has a more specific name or meaning in geometry, though. It talks about the sides and the angles. Yeah, they're all the same size. So all the sides are exactly the same length. Take these out, please. And all the angles are exactly the same. Okay? That's what regular means. So we're talking about not just any old Joe, plain old Joe polygon, but one that has all exactly the same length sides and all exactly the same measured angles. And so the radius of these polygons is the distance from the center of the polygon to the vertex, to a vertex of the polygon. Now, you'll probably hear me pronounce this word a couple different ways. Apithum is the way I normally pronounce it. Apithum. I've also heard it apothum. I honestly don't know which is. Well, actually, I think we looked it up and they said either is acceptable. Okay. So anyway, that's what these words. These words are important to what we're going to be looking at here, and so I want to make sure we get a copy of this picture so you know where to find the apithum, where the radius is going to be. Okay. And we notice that this is a hexagon. It has 6 sides, and that the hexagon is circumscribed within this circle. So the circle is around and passes through each of the vertices of this this hexagon. Okay? I'll let you finish that and we'll move on to an example. So the area of a regular polygon is half the product of the apithum and the perimeter. Okay? So A is the apithum. P is the perimeter. Does anybody need anything above? Okay. Copy this down, then we'll find the area of this polygon. Okay, looks like most of us are done copying down the picture. Let me ask you this, just to make sure we understand what's happening here. This is the center of our circle. What is this side called? Okay, the apothem or the apothem, so we'll label that A. Okay, what is this side called? The radius, so we'll label that R. Okay, and to use our formula, which is right above us here on the screen, area equals 1/2 AP. Is R part of that perimeter? No. So R isn't something we really need for the formula, is it? But do you agree it's the only thing they gave us here?
Yeah.
So in other words, we have to find A, don't we? We have to find A, and this side here is how much of this? Half of it. So if I knew this little bit right here, let's call it X. If I knew X, that would allow me to find S, the length of this side, wouldn't it? Let's say X was 4, then S would be how long? 8. Okay? And if S was 8, how would I find my perimeter?
Times that by the number of sides.
Yeah, nice. And I like the fact you said the number of sides instead of 6. 6 is the number of sides, and it'd be appropriate here, but by knowing the reason we're doing it, we have however many sides we have, in this case 1, 2, 3, 4, 5, 6. If we multiply that by the number of sides, we'll get the perimeter. Because all the sides are the same length, right? That's why they told us it's a regular polygon, so we know that. Okay. So, what I want to do, I'm going to roughly trace this if I can. I'm going to pull this over here. Actually, let's go up here so we can all see a little better. And so, A, X, and 24. Now, did they tell us this is a 30, 60, 90? No. Did they tell us it's a 45, 45, 90?
No.
No. Do I have two sides, so I can use Pythagorean theorem to find the third side?
Yeah. Or you have one side.
Yes, but I need 2 to find the third side, right, using the Pythagorean theorem? So I don't have that either, do I? So here's what we have to realize. If we drew all the radii, we drew all these in, looking at the red lines, how many equal pieces of this polygon do we have? 6. So by drawing all those in, we have cut this into 6 equal pieces. Well, how many degrees are in this lane-looking circle I drew there? 360. And so if I take 360 and divide it by 6, I get 60. So that means each of these angles are 60 degrees. Anybody disagree with that? Anybody confused on what I'm saying? Okay, let me clean that up just for a moment. Okay. Try it again with a smaller eraser. Alright, and then we'll say this is 60. So if that's 60, what is this? 30. And now so we can label this 30. So now if I look at my triangle, I have a 30 and a 90. What's this one have to be? Louder? 60. So the reality is I do have a 30, 60, 90, don't I? Okay? All right. So let's use that now to find x. Remember the rules for Remember rules for 30, 60, 90? There's 2 of them, right?
Yeah.
Sorry. have a little more room to work here. What's the first rule for 30, 60, 90?
Hypotenuse equals 2 times short length.
Hypotenuse equals 2 times short length. So in this picture, someone other than Anthony and Jackson, what is hypotenuse? It's the, okay. Slow down. I think I heard longest leg. And I think what they meant to say is longest side. Where is it always located? Opposite the 90, across from the right angle. Okay? So in this case, that's 24. All right, good. And then 2 times the short leg. Remember, pictures sometimes are deceiving. So where do I find the short leg? Opposite the smallest angle, which in this case is the 30, and so opposite the 30 is x. But when I write that little equation, I only have one thing missing, don't I? I know 24, I know 2, and I don't know x. So how do I solve? Divide by 2. So x is equal to 12. Okay? So x is equal to 12. Okay? So what does the length of the side equal then? 24. Okay? So the length of that side equals 24. Well, we'll get to that in a second. Let's go back to this triangle. We also need to know A, don't we? Right? Look at the formula down here. Area equals 1/2 AP, apothem times perimeter. So we have to know what A is, the apothem. And so what's our other rule for 30, 60, 90?
Equals square root of 3 times the short length.
Nice. You guys aren't quite all in unison, but I like the fact that there's so many of you answering this. So in the picture here, what's the long leg? A. And the short leg we said was x, but we just discovered that x was 12. And so A is equal to 12 square roots of 3. Okay? So A is 12 square roots of 3. Now we've done all that work. Never know how far to go, how far it's going to go on its own. So let's substitute in. Area is equal to 1/2 A, and A we just discovered was 12 square roots of 3. Oh, perimeter, we haven't found that yet, have we? We said, that's right, we said perimeter was 6 times the length of one side, which we just discovered to be 24. Let me clean that up. 6 times 24. Did you say 144? Yeah, I heard that, and so as I started writing 24, I put 1 for 144. So I agree. 144. So that's my perimeter. Now, here's the thing. They will probably say on a lot of these, leave your answer in simplest radical form. Okay? Simplest radical form. So that means I'm going to say 1/2 of 12 is 6. Please do not do this. Do not think about this as distributing. It's not distributing. We're not adding in the middle there, timesing by the quantity. It's a multiplying all of it. So it's a number times a number times a number. Once you multiply the first 2 numbers, you have a new answer, which you'll multiply by the last number. Okay? So do not think of that as distributing. So 1/2 of 12 is 6. times square root of 3 times 144. And so then we would say 6 times 144, because they're both outside the radical. So 6 times 144, I could use a little help on that. 24, 864. And this was in feet, and it's area, so it's feet squared. Okay? So it looks like that. Now, if they said to round to the nearest tenth, some of you on your calculators, you've not done this before, especially if you've had Mr. J. To get your calculator not to have a square root in it, you have to go Control Enter. And you'll notice above the inner sign there's a little squiggly equal sign, which means approximately equal to. And so if you want the decimal, you sometimes have to hit Control Enter to get that. So right now, for funsies, tell me what is this approximately equal to? 1,465 point what? We want to go to the 10th. 3? Does anybody disagree with her? That's not what you got? Okay, let's double check it. Let's try it one more time. Make sure we use the square root symbol. 864 times square root of 3. Oh, okay. She accidentally typed in the wrong number. So, tell me again what you guys got. 1,496.
0.49.
So round to the nearest tenth. 0.5. Okay? Good. Any questions on that? The only thing I want to add, that was the only example I'm going to do for you, but I want you just to look at the setup for this. You don't draw these diagonals. I'm just doing this so I can locate the center a little better. Pretty close. If we how would I find this angle in this picture? Justin? Okay. He's saying divide the square root of 4. So what he's saying is if he drew all these out, there'd be 4 equal pieces, right? So to find the measure of that angle, we would say 360 divided by 4, which is 90. And then this angle then is going to be half of that, right? Which is 45. So if this is 45, what's this one?
45.
So now I'm not looking at a 30, 60, 90. I'm looking at a 45, 45, 90. Okay? All right. We're not going to finish this. You'll get a chance to practice some of that. There's 11 questions here. Give you a chance to work on that. We'll do a few more tomorrow. If you don't finish these today, it's not a big deal. You're not going to have notes time tomorrow. So you'll have all period to work on what I'm giving you tomorrow and to finish this. So you don't have to worry about taking it home, getting it done. Unless you know you're not going to have time tomorrow night to get anything done, then yeah, you should maybe work on it tonight. And then get as much done as you can. And then tomorrow, you'll have all class time just to work on tomorrow's assignment. You'll probably get it done in class.